Compute the indicated derivative using the chain rule. Part A, we were given y equals u cubed. U is x minus 1, and we're looking for dy dx. Beside y, there are two variables u and x, and so dy dx is dy, the variable of the function y is u, and so we would rewrite this as dy du times the variable for the function u is x, so this is du dx. The way to remember this is that even though this is the notation, but if we assume that these are fractions, then we end up with dy dx here, and that is what we want. Now, what is dy du? If y is u cubed, then dy du is 3u squared. Similarly, du dx is the derivative of u. The derivative of u with respect to x is the derivative of x is 1, and the derivative of 1 is 0. And so this is dy du is 3u squared, and du dx is 1, or 3u squared. But we can't leave the answer in this form because we were given that u is x minus 1. And so that is the final answer. For part B, y equals 3x minus 2. The question asks us to find dx over dy, which is the derivative of x with respect to y. The derivative of y with respect to y, same variable, is 1, equals 3. The derivative of x with respect to y is dx dy, and 2 is a constant, so its derivative is 0. Dx over dy is therefore 1 over 3. We see that this function is in terms of x. If we were to find dy dx, we would see that it is 3. And so dx dy, the reciprocal rate is 1/3. In this case, if we're taking derivative with respect to the same variable, then we would take derivative like we would normally do. But if we take derivative with a different variable, for 3x, the variable is x, but we are differentiate with respect to y. And so we would need to put dx dy. For part C, we were given x and y, and we're looking for dy dx. X and y are in terms of t, and so how do we get dy dx in terms of t? For x, if we differentiate with respect to t, we'll get dx dt. And for y, if we differentiate with respect to t, we will get dy dt. And again, even though these notations are not fraction, but we see that if we were to treat them as fraction, then dt canceled out, and we end up with dy dx. But what is dy dt? Dy dt is the derivative of y with respect to t. Y is negative 5t, so its derivative is negative 5. Dx dt is the derivative of x with respect to t. The derivative of 2 is 0, and the derivative of 3t with respect to t is 3. And so the answer is negative 5 over 3. Lastly, for part D, we're looking for dy dx evaluated at t equals 1, but we're given two functions x and y, and so we rewrite this as dy dt over dx dt. Again, x is a function of t and y is a function of t. If we obtain that, we plug in t equals 1. But what is dy dt? It is the derivative of y with respect to t. Y is t cubed. The derivative of t cubed with respect to t is 3t squared. Similarly, dx dt is the derivative of x with respect to t. x is t squared plus 2t, its derivative is 2t plus 2. We then evaluate this at t equals 1. 3 times 1 squared over 2 times 1 plus 2, or 3 over 4.